Baby shawties, how we doing? Welcome to our second video lesson on right triangle math. Today we're actually going to get a little bit sassy. Our focus for today is going to be on what's called trigonometry and specifically the trig ratios. So the trig ratios, when you hear the word trig, that is just short for a part of math called trigonometry. Now, what trigonometry does is it's going to start to relate the side lengths of a triangle to the angles within a triangle. And specifically here in this chapter, we're looking at right triangles. So it's going to look at the relationship between the side lengths of a triangle and the angle form. So for example, this is something actually we talked about when we started focusing on triangles, that we have actually a relationship between the angled form between two sides. So say, for example, I have here the angle formed. And what these trig ratios are going to look at is the relationship between that angle and the three sides. So think of this as kind of like a door hinge. That a simple way to look at this is one of the ratios we're going to talk about is that the opening formed by this angle, you can relate that to the opposite side of that triangle, which is the side across from that angle. And that the greater the angle is, the larger that opening is going to be, which means that third side is going to have to be a little bit bigger. Same thing if I were to go in reverse. So what's going to happen here is that the trig ratios are going to relate that angle within that triangle to not only the side across from it, but to the side next to it, as well as within a right triangle, what's called our hypotenuse. So the trig ratios, again, are going to relate any angle within the triangle except for the 90-degree angle. So in all right triangles, again, we have our 90-degree angle. But what we have are two acute angles, meaning that these two angles have to be less than 90 degrees. What the trig ratios are going to do is it's going to relate these angles to the lengths of the sides. So for example, let's say that I look at angle A. So what we're going to do is, let's say we want to relate the amount of degrees of angle A to the lengths of the three sides. Now, real quick, some symbols you're going to see. For angle A, you might see this Greek letter, it's called theta, being used within here, okay? Theta is just our symbol that's going to represent angle and is always going to be measured in degrees. So for example, we could say, okay, this angle is 30 degrees or whatever degrees it's going to be, but that's the symbol you're going to use. But we could say this, okay, if that angle is, let's say, 30 degrees, well, what would that mean if that angle is 30 degrees? How would that relate to the side lengths that we see here? Okay, so there's some side lengths, some terms we're going to use. So across from that angle, we're going to call that the opposite side. The side that's next to the angle is called the adjacent side. And the adjacent side is going to be the one that is next to it, but is also not the hypotenuse. And the hypotenuse is going to be that third side that we talked about in terms of Pythagorean theorem, which is always across from the 90-degree angle. So what these trig ratios are going to do is it's going to relate that angle to the length of those three sides, okay? Now, in terms of the Pythagorean theorem information we talked about in our last video lesson, you can think of the adjacent side and the opposite side as our legs, and the hypotenuse as that longest side across from the 90. You also remember that when we had Pythagorean theorem, we had the a squared plus b squared equals c squared. So think of this as like the a, the b, and the c, where a was our shortest side, b was our middle length side, and c was the longest. We're just using different words now. We're going to use the opposite, adjacent, and hypotenuse because we're going to relate those side lengths to the angle. So always remember, opposite is across from, adjacent is next to, okay, but next to, but not the hypotenuse. The hypotenuse is always across from 90. All right, there's going to be three trig ratios that we're going to look at. We're going to look at two of them within this video lesson here today. So the first one we're going to look at is what's called the sine, and we'll introduce what the sine does. But then there's going to be what's called the cosine, and then lastly the tangent. Okay, so each of these three things are going to relate differently within that triangle. But the overall purpose of all three of these is to relate the angle within the triangle to the three sides of the triangle. All right, so again, get a visual of what's going on here. This is just a little simulation that shows the relationship of all the things we're going to see. So you'll see here on the upper right side, we have the three ratios. Now they're written in a shorthand notation, which we will talk about. We have cos, which stands for cosine, sin, sine, which stands for sine, and tan, which stands for tangent. Okay, and again, what they're going to do is relate the angle of a triangle to the three sides. So you'll see here that I have this little marking right there, which is representing the angle. And on this side, it kind of shows the value. So in terms of degrees, we have 34.5 degrees. And why I wanted to show you this is because it's going to show you arrows here to kind of represent the length. So let's say we start off with the first one, which is sine. Okay, so sine, you'll notice that all of a sudden I have the green arrow. So the green arrow represents the opposite side. Okay, and what again these trig functions are going to show is that if I were to, let's say, change the angle by rotating this red dot, notice how the angle is small to a bigger angle. Notice what happens to the green arrow. The green arrow, as I make a larger arrow, gets bigger. As a larger angle, it gets bigger. And as I make a smaller angle, it gets smaller. Okay, so it's going to relate that opposite side. If I were to click on cosine, notice I have the blue arrow, which is the adjacent side. And again, as if I go through this relationship, for a small arrow, that adjacent side is big. As I move to different degrees, you'll see that that arrow changes length. So sine and cosine, which is going to be our focus for today, are going to relate the opposite side and the adjacent side. Tangent, which is the sassy one of the three, notice that both arrows are shown. So it's going to look at the relationship between both of those arrows at the same time. All right, so the first trig ratio we're going to look at is the sine. All right, so when I showed you that little simulation, here's kind of what's going on. The sine is going to relate the opposite side of our triangle to the hypotenuse. And it's all based upon one of the two angles within our triangle. So let's say here that we are looking at this angle right here. And again, the angle you'll see is noted with this little Greek letter theta. Okay, so what the sine is going to do is it's going to relate the opposite side to that angle. So opposite means across from, and it's going to relate the length of that side to the length of the hypotenuse. Now, the reason why it's called a ratio is because we are literally going to write this as a ratio. Now, ratio is just a fancy way of saying a fraction. Okay, so what we're going to do is we're going to look at the ratio of the opposite side to the hypotenuse. So notice I'm writing this as a fraction. Okay, now what we're going to do is it's going to relate the angle measurement in degrees to the ratio of those two sides. So the way it's written is like this. Instead of sine, you're going to see S-I-N, which is just a shorthand notation for sine. All we did was drop the E. And then you're going to see that Greek letter theta. So the way this is read is the sine of theta. Or let's say we had a certain degrees. Let's say the sine of 30 degrees. And what this equal sign is telling me is that the sine is going to give me the same ratio as what I would get for the opposite and the hypotenuse. So I'm going to give you just a quick example here. Let's say that I had a right triangle, and let's say that my angle measurement, here I'll put a right angle there. Let's say that my angle measurement was 30 degrees. And let's say then that my opposite side was 5 and my hypotenuse was 10. So again, the sine is going to relate the opposite side to the hypotenuse, okay? So the way this works is this. So that within this triangle, the sine is going to relate the angle. So it's going to be written sine of 30 degrees is going to equal the ratio of the opposite side to the hypotenuse. So that would be written as a fraction, 5/10. All right, so now this looks new, and this is new, and it looks a little confusing. So what does this mean? So on the left side, the sine of 30, this is the trig ratio. This is relating the degrees, so our angle of 30 degrees. Now the sine is specifically designed to tell us what the ratio of those two sides is going to be. And this is not something I expect you guys to do in your head or know right away, but this is actually something that is in your calculators. Your calculators are actually designed to find sine and cosine. So you'll notice here I popped up a little calculator, okay? So you'll notice right here, it's on usually the same spot on every calculator, but above 7, 8, 9, you'll see sine, cosine, tangent. Same thing here. So when you would type that in, obviously you would hit the sine button first, and then you type in your degrees. Normally it'll pop up like you can see on the screen, sine, and then parentheses. So you would type in sine, parentheses would pop up, and you just type in 30. Don't have to hit a degree button at all. Okay? And what it's going to do is it's going to give you a decimal. The best way I like to think of this decimal is as a percent. Okay? So when you type in sine of 30, it's going to give you a decimal of 0.5. 0.5 is like saying 50% or 1/2. Well, here's what's interesting. 5 over 10, as a fraction, 5 over 10 is the same thing. It is also 1/2 or 0.5. So the sine is developed to tell you what percent of the hypotenuse would that opposite side be. So for example, if the hypotenuse is 10, the sine of 30 is going to give you 0.5, which is the same thing as saying 0.50, which means that my opposite side is going to be 50% the length of my hypotenuse, which is 10. So what we're going to do is we're going to use this trig ratio, I should say. We're going to use the sine to try and solve for things. So in this first example, we're going to use the sine ratio to solve for these unknowns. And we're going to use the sine ratio to solve for the side lengths. And this is where these trig ratios are important. Okay, so first of all, the angle we are given in this first example is 26 degrees. So 26 degrees, again, that's a little bit different than the 30 degrees I was using. But what we're going to do is we're going to use the sine ratio. So again, the sine ratio says the sine of my angle is going to relate the opposite side to the hypotenuse. So based on 26 degrees, what I always like to do is draw arrows. Based on this, x is my opposite side, and 14 would be my hypotenuse. And why my hypotenuse is because it's across from the 90-degree angle. So the way we're going to set this up is we're going to type in, okay, the sine of my angle is given to me as 26 degrees, is going to equal the opposite side x over 14. So I write the sine of my angle, and on the right side I write as a ratio the two sides. X, which is not given to me, which I'm solving for, and 14, which is the hypotenuse. So here's how this works. We're going to start off first by typing in the sine of 26 into our calculators. Again, this is something you cannot do in your head. So if I type in the sine of 26, it's going to give me a decimal. And the decimal I would get here, and this is a rounded answer, so don't freak out, but I get 0.44. Okay? So think of that as 44%. Decimals can be expressed as percents by just moving the decimal over to the right 2 spots. So think of it as 44%. Well, percent is always something expressed out of the whole. So think about 14, my hypotenuse, as the longest of the 3 sides. Okay? So if I want to find what is 44% of 14, all I'm going to do is I'm going to take my decimal of 0.44 and I'm going to multiply it by that hypotenuse, which is 14. And that's going to tell me what x is. Okay? So I take that percentage and I multiply it by the whole, which is 14. And here, just rounding it, would get about 6.1. I'm just going to round this to the 10 spot. Okay? So that means that this side length for x would be 6.1. So notice here that I use that sine of 26 degrees to find a percent, which you can find the length. So this is neat because I'm using the degrees to relate to the side length, something that we haven't done yet, relating angles to sides, other than knowing that the angle is going to form either a longer third side or a shorter one, but now we're actually getting into solving for the actual lengths. Now we're also going to take this and try and solve for y written down here in the bottom of my triangle. Now the sine is always going to relate the side opposite of whatever angle we're given. So notice with 26 degrees, the opposite side was written over here as x. So in order to find y, I need to know, relate y, which is the opposite side, to the angle that's opposite it. So I need to relate y to this angle here at the top of my triangle. But notice there is no angle given to you. However, we do remember, hopefully, that there is a relationship between angles within a triangle, that if I want to find that angle, I can know, okay, I got 26 degrees already. We already know that that right angle is there, which is 90 degrees. So right there, I have a total of 116 degrees. And I should remember that all triangles have a total of 180 degrees inside. So that means the third angle that I'm trying to figure out here, if I subtract those two, would give me 64 degrees. So I know this angle right here should be 64 degrees. Now that's important because I want to relate the opposite side to that same hypotenuse. So now if I set this up, okay, I'm going to set this up by writing the sine of my angle, which is 64 degrees. And I'm going to relate that now, instead of x, I'm going to relate that as y, to the same hypotenuse of 14. Now the sine is 64. Because this is a new angle, I'm going to get a new decimal. So in this case, I'm going to get a decimal that is equal to 0.90. And I had to round that. If you type that into a calculator, you should get about 0.898. So I rounded up to 0.90. So think of that as 90%. 90% of my total, or my hypotenuse, which is 14. Now, quick side note. This is when I talk about percents, this is where it gets a little tricky for some students. 44% and 90% do not add up to 100%. That's the one issue with when I'm talking about percents. That's the one issue that doesn't make sense a little bit, is that the percents don't add up to 100. Okay? Me teaching it as percent is just a simple way for some people, especially new students, to understand the trig ratios. Is a good way to kind of understand it. So here again I have, when I type this in, sine of 64. Doesn't matter that I wrote the degrees there, but I get 90%. So then all I got to do to actually find y is I need to take 90% of 14, which means just multiply, and that would give me y. So in this case, I know that y is going to equal 12.6 whatever units we would have, but that's going to be the length of y. Okay? Now, the neat thing about this, too, is that because I'm relating angles inside, it actually goes back to Pythagorean theorem as well. We now know the side lengths of all three sides. We know that x is 6.1. We know that y is 12.6. So this actually follows Pythagorean theorem, that if I were to do 6.1 squared plus 12.6 squared, I should get the same answer as if I were to do 14 squared. Okay? So it all ends up working out. What we did with Pythagorean theorem and what we did with so far the sine ratio all kind of works out. All right, the next trig ratio we're going to look at is what's called the cosine ratio. So the cosine ratio is going to be very similar to sine, especially in how we set things up. The only thing is going to relate a different side. So sine specifically related the opposite side of my angle. So again, if my angle was this bottom left corner of the triangle here, sine related the opposite side, which was across from. Cosine is going to relate the adjacent side. So adjacent means next to. Now, this is my angle right here. So there are technically two adjacent sides. This angle is next to this side on the bottom and this side here. Okay? So specifically when we say the adjacent, we are always talking about a side that's next to, but that's not the hypotenuse. Because again, the hypotenuse is always across from the 90-degree angle. So in this case, the adjacent side is going to be that bottom edge of the triangle, the one that's next to the angle, that's not the hypotenuse. It's going to be set up and written the same way as sine. We're going to look at the cosine of the angle, and it's going to relate as a ratio the adjacent side. I'll just write ADJ for adjacent to the hypotenuse. I'll just write HYP for hypotenuse. And again, it's going to relate it as a ratio, that the adjacent compared to the hypotenuse is going to give you a decimal, and the cosine of that angle should give you the same decimal. So let's just give you just a quick example here. Whoopsies. Let's say that I give you a triangle that looks like this. Here's my right angle. And let's say I give you a 60-degree angle. And let's say that my adjacent side is 6 and my hypotenuse is 12. How this works out is that the cosine of 60 degrees, if I were to type that into a calculator, again, cosine, which should be right next to sine, is going to give me a decimal of 0.5. Think of that as 50%. And it's going to relate that as a ratio to the two side lengths, 6 and 12. Well, 6 and 12 is, again, 1/2, which as a decimal is, again, 50%. So the idea is it's going to give you the same ratio, same decimal every time, and our goal is to be able to use this to solve for unknowns. All right, I'm going to solve the same problem that we did before. Same thing, example 1, but now we're going to use the cosine of our angle. So notice the angle here again is given to you as 26 degrees. So the cosine is going to relate the adjacent side, and adjacent means next to, and it's going to relate that to the hypotenuse. So understand here, this is my adjacent side, and this is my hypotenuse. And again, x would be the opposite side based on that angle. So we're specifically looking at the adjacent side. So notice here, we're going to be solving for y first. So to set this up, we're going to write the cosine, and our shorthand notation for cosine is cos of that angle 26 degrees, and we're going to set up the ratio. That's going to equal the ratio of y to 14. So what we're going to do is, again, in our calculator, we're going to type in cosine of 26. Cosine of 26 is going to give me a decimal, which we can think of as a percent. So rounding again, you're going to get 0.90, which is 90%. And percents, again, are always expressing something out of the whole. So again, we're trying to figure out what is y compared to 14. And what 90% means is that y is going to be 90% the length of 14. So I'll just take 0.90 times 14, and that would give me y. So therefore, y is going to equal 12.6. And you'll notice that compared to what we did before, we got the same exact answer. We're just solved for y in this case first because technically y is the adjacent side to that angle. Now let's say I want to solve for x. Now I know we already solved for x in the previous example, but let's solve for x using cosine. So again, cosine relates the adjacent side of the angle. So y is the adjacent side to 26. So that means x is the adjacent side to this angle up here. Now based on our previous example, we already know that this angle is 64 degrees. So that means x is the adjacent side to 64. And it's going to relate that to, again, the hypotenuse. It's always related, in this case, to the hypotenuse. So I would set up cosine here of 64, but instead of solving for y, we're solving for x. Now, the neat thing about this is that when I do the cosine of 64 degrees, I'm going to get a percentage of 44%, which is what we got for the sine of 26 in our previous example. But again, 44% is just expressing x out of the whole, which is 14. So all I got to do is take that percentage and multiply it by 14, saying, okay, 44% of 14 is x, so therefore x would equal, rounded to the tenths, 6.1 units. So you'll notice that I get the same exact answer. Just the only difference is that when I solved it the first way, right, I got 6.1 first and then 12.6, and I'm getting the same answers. I just solved them in a different order. So when you get problems like this, here's what you can do. Instead of doing what I did, you could take, okay, I can say, okay, if I'm given 26 degrees, well, I can use the sine to solve for x, and I can use the cosine to solve for y. And that is because, according to this angle, x is the opposite side, y is the adjacent side, and because this is the 90 degrees, that means 14 is going to be our hypotenuse no matter what. All right, so in this last example, let's do just that. Here you're given a triangle. You're given the top angle here of 65 degrees, and our goal is to solve for u and t. Now, what we're going to do in this one is we're going to use sine and cosine, okay? So based upon this angle, here's the way I like to do it. I like to draw an arrow straight across, okay? So I know that t is going to be considered the opposite side. I know that u, being next to the angle, is the adjacent side. And because 8 is across from the 90, I know that's the hypotenuse. So, for example, if I want to use, let's say, the sine. So let's say I want to do sine of 65 degrees. Sine is going to relate the opposite side, which is t, and it's going to relate that to 8. So then to solve, I would just take the sine of 65, which is going to give you a decimal again. So that would give you about 0.91. Okay, that's rounded again, so 91%. And that's going to relate that to 8. 8 being the total, we're going to take 91% of 8 to find out what t is. And that means t in this case is going to equal about 7.3. And again, that's rounded to the tenths. Okay, so be careful, especially in big ideas. Pay attention to where they want you to round these answers to. All right, so that's using sine. Now I'm going to use cosine of 65 as well, because cosine is going to relate the adjacent side. So cosine will allow me to solve for u, and again, it's always going to relate it to the hypotenuse, which is 8. So the cosine of 65 is going to give me a decimal, which you think as a percent, which will be about 42%, and it's going to relate that to the length of 8. So I want to take 42% of 8. That should tell me what u is, or what u are. I don't know. But that means u is going to equal about 3.4. Again, that is rounded. So here I use sine and cosine to find the lengths of t and u. So again, here we introduced the whole idea of sine and cosine, which are our first two trig ratios, which relate the angle of a triangle to the opposite and the adjacent side. And then again, it expresses it as a percent of the hypotenuse. Kind of some new stuff, some funky stuff. So make sure if you got questions, jot those down. We'll see you next time. Peace out.